Hello, mic check. One, two, three, mic check. So, hi guys, it's Jasu here. So, today in this video, we are going to cover linked list. So, basically, we are going to cover the linked list operations such as insertion, deletion, and traversal, and also some advanced topic such as reversal, removal of duplicates, and like that. So those of you guys who don't know what linked list is, I have created separate short for that. So if you want, you can check it out. Basically, linked list is a data structure which helps to store data in a con non-contiguous manner. Or like we can set in the memory wherever we want, where each node point out to the next node. So I think you have an idea. If you don't have, please research and come back to this video. So in this video, we are covering these operations. So without any delay, let's get started. So basically, what is linked list? So linked list is a node. So linked list is a data structure which contains nodes. So here one node contains a pointer to the next node. So here what we have to do is create a node. Okay. So let's create a node. Now it will be very confusing, but after some times everything will make sense. So just come along with me. Okay. So let's do create a class called node, and so oops, in that we can create a constructor which is used to work while making an instance of this or while invoking this class. So in node, basically in DSA, in linked list, specifically in linked list, a node which in the sense which will have a pointer to the next node. So first of all, we have to assign the value for that node, right? So this dot value assign value. So we are giving the value, and the next thing is as a part of this linked list or a node contains two portions such as one portion for the value and one portion for the pointer to the next node. So here this will be this dot next assign null. So initially this will be null, and on go we will set this like references for the next node. Okay. Now we have to create another class such which called linked list, and which will have a constructor. Oops, no problem. So which will have a constructor which will keep the root node, uh, basically this dot root assign new node or null. So not new node. So initially when we call this the root will be null, sorry. So why this is, or what is this, we are setting a reference to the root node. So if we call this dot root, we will be able to do that. I mean, we will be able to get the root value. From root we will jump into that. So oh, I have making a mistake here. It's not root. Yeah, you can call it whatever you want, head or root or anything. So yeah, and also if we want, we can create a tail also to get the reference of the last node, but I think it's not needed here. If you want, like, it's pretty simple, just keep the reference right there. So yeah, now what we have to do is, so here we have created a kind of a skeleton of what we can say linked list. Yeah, now here we want to insertion, first insertion, then insertion at beginning, then end, and with a position. So let's clear insertion firstly. So sorry, insert will have a value. Okay, now we want to create a new node. Const new node same new node of value. I will explain. I know you are not. If you are not able to come along, I will explain at the end. Now what we have to do is we have created the node. Now we have some base conditions such as what if the root node is null. So if the root node or the head is null, this this dot head is equal to null, we can say this dot head as in new node. No problem, right? No problem, right? So yeah, it works perfectly. So here we have assigning if there is only single node, we will set into the head. Else, or if it's not work, we can say that we can return something else, or we can write in the else condition. Yeah, that will be better. I mean, that will be more readable. So here what we want is, so here we have L node, right? So basically I have said that, or what I have mentioned is, first we will have a head which contains the top or the first initial value, initial node, and it will have two portions such as the value and the next the reference to the next value. So here we have to iterate till the last element of the node, so and then insert it, right? So insertion in the in this case we will insert at the last. Okay. Okay, then now what we have to do is set a reference to the current, which means we have to iterate through the whole. Okay, so here why we are creating a new variable and setting the head into it. So here we are creating a kind of reference. So the head will be there. We are going to iterate through the current variable, which is best practice, I would say. So yeah, if you want to do that, go ahead. No one is stopping you. So we can iterate through the through it. I mean, dot next, no, and current, same current dot next. So yeah, that's all about the iteration. After, so this means there is no after the end case. Here will be there is no next value in this node. So if there is no next value, we can what we want we need to set as next the new node as next node, right? Now you got an idea, right? So let's see if it's working or not. Then check. So const, let's say what we can call linked list. So for shorten LL for linked list, and we will create a new instance of linked list. Okay. So what will happen here? Here the constructor will work while creating the instance, and we will have the head thing. So the initially head will be null. Okay. So now we are going to insert uh, L LL stands for linked list, and insert a value, or so we can say 23. Okay, now let's console it. Log ll dot head. Ll dot head means the head of this. So this we are setting this to here, and after this node everything will have an reference, which in the sense if the second node appears, the next node, the next will be the pointer to the next node. So here we can get the values from it. I hope you understood. Now let's check if it's working or not. Node linked list.js. Yes. Yep. This is working properly. For now, no problem. So that's the main thing about insertion. Now let's see what's happening behind this. So here we are going to insert, or yeah, after, so we have created an instance for linked list. Here the head will be set to null, and if we insert this, it will check. First of all, it will create a new node, which and we will pass as value, and in new node the constructor will work, and here we will set the value as value, and the initially the next will be null. So the new node is here, right? Now, if the head is null, which means if there is nothing in the linked list, we will set the head as the no node, which is the starting case. And else, if there is any list, or if there is any nodes exist, we will iterate till the end, which in the sense, if there is we will iterate till current dot next is null. I think you got it right. We will iterate that. Then we will set as current dot next as a new null. So we will insert the new null into it. So that's what really happening here. If you really check uh, here, the new node. Let me clear this. Oh, and yeah. So here we have a root node which contains the value, and the next will be a reference to the next node. Okay. So here the next node is here, and after this the next node will have the reference to the next node. So it will display like this. So this is what basically linked list is. I hope you got it. So that's all about the insertion, and yeah. Now let's see what we have. Let me mark this insert. Oh, I haven't do this. So what we have covered is insertion at the end. Now insertion at the beginning. So let's check that. Let me change this to at end. Okay, perfect. Perfect. Yeah. Now let's insert it in the beginning. Insert at at, at yeah. Let's say at start. So which will have a value. Okay. So what we want here? Here we want to insert a node. So if in this case, in the normal case, in the insert at the end, what happens is the new node will be here. It will be as next reference. But what we here we want is the new node need to become here, which in the sense the first place. Then the other thing should be need to be inside the next reference of that new node. I hope you got it. So let's say, yeah, let's do this. Let or const. Let's say let new node. First of all, what we want is a new node, right? New node a same value. So we will pass the value. So here what will happen is we will work this as same before, and in order to work this, first we have a loophole. So we will cover the loophole at the end. Let's see the non-loophole area where the list contains more than one value, or more than I mean the list contains none, or yeah, you got it right. I mean nothing, just clear everything. Let's start with the loophole. So if there is no uh, node inside the linked list, we will what we will do, we will insert it, because that's what we wanted, right? Head assign new node. Okay. So yeah. Now else, if not, if the linked list contains more than a value, or more than if the linked list contains one value, what we have to do is same. So here what we have to do is new node dot next. Okay. So here the next of the reference, or the next of the new node will give the reference to the head, this dot head. So here what happens is this dot head contains one value. After this second insertion, new node, which means this dot head contains the first value, right? Now the new node dot next contains, assign or refers to the head. Yeah, I will set that to head. Okay, wait, I can show you that. This dot head assign new node. Okay, so here it's working properly. Let's check, and else it will work. And yeah, that's all about the insertion at start. Now let's see it will work or not. We can say 1111. So this value must be here. Need to be here. Else it is not working. Yes, I think you got it right. So this is the insertion at first, and the next will be this. So here what's happened is this dot node next. So initially this will be a node which have a value and next of null. So we will assign the next into this dot head, which contains this much. So what happens if new node occurs? We will create a new node, and the next reference will be to the head, which contains all the values, right? Which is pretty simple, right? So yeah, that's all about insertion at start. And yeah, let's mark this. Now insertion at the position. So how we can do this? So here the user will give an input or a position where we want to insert our node. So let's see, insert index, which will have a value and an index. Okay, so I think you got it right. What we want is if the user gives an index of 2, it should be it need to be insert in here in the middle of this, and after this node should come, right? After the new node, this node need to become as the reference of the new node, as the reference of the next of the new node. It will be confusing. If you practice along with me, you will be good as me. I'm not perfect. There will be some errors, minute errors, but yeah. So here what we have to do is create a new node. That new node assign this dot. No, not this dot now. New node of value. So here we will create a new node, and now what we want is iterate till the what iterate till the index. So yeah, let's see. So we can set to keep the we can set a value or a index, or we can set a variable to keep the reference or to keep the count, to keep the track of the uh, positions. So let's see, or we can do anything. Oh no, let's not make this complicated. Let's say position assign 0. Now while we want one more thing. Yeah, you guessed this. Right. You guessed it right. We need the reference of the head, which we need to iterate through. So yeah. So here current till current is the we need to iterate, and also uh, another condition is the uh, position not equal to index. So here, yeah, I will explain at the end. That will be better. Now what we are going to do is current assign current dot next. Okay, so we'll increase the position till it reaches. So we'll give uh, first index as 1. So if it's 1, we will what if there is, if now we have a loophole here, or what we can say, we have a fail case here, or if there is nothing inside current, yeah, it's a loophole, right? So we can give it at the end. Let's see if this dot head is equal to null. What we want is to return, or is to create the value as this. So this dot head as a new node. As a new node. Yeah. Uh, Else we can say that invalid index. That will be good. That is what we wanted to do. If current do not exist, or null is equal to null, yeah, that's great. We can return that invalid position. Okay, cool. Now else we have to, as next we will give the new node. Oh, here we have one more problem. So in this case, we have a node, right? If we have a linked list, we if we insert this, we will set that. Yeah, let's say not a problem. We will insert here. But after this node, we have. Let's assume that we have 5 nodes after the position. So in order to get the position of that, or in order to get the reference, what we are going to do is, let's see next. So we will let temp, we will give a temporary variable which have current dot next, and current, and we will current dot next assign current dot next assign new node. So no need of time. Oh, that's cool. New node. Okay, new node of next, we will set the other portion of this, and we will set into the middle element, or the position, sorry, not the middle. We'll set into the position that the user given. Yeah, let's see if it's working, and if it's work, I will try to explain as much as I could. So I hope this should work. I mean, this must work, right? So let's see, I want to insert in second position. So here first we will give the value which is 2222, and we'll give the index as 2, or yeah, 2. Yes, it's working properly. So I think if this will be a confusing thing after this. So 1, 2. It's the new nodes need to come here after 3. Let's see. Yeah. Okay, so it's working. Now let's check the loophole, or the break condition, where if the root is null. Yeah, null. So why it's null? We are returning something invalid position, right? And so if we log it, it will say that, hey, the position is invalid. Yes, position is invalid. The null is because the root is null. That's why. So yeah, let me take that back, everything. So yeah, this is all about the insertion. Now, wow, we are completed one segment of this series, or of this video. Now what we want is deletion operations. So yeah, it's basically pretty say it's same as it is insertion. yeah, we can do it quickly. So first we are going to cover deletion at beginning, deletion at start. So here we don't have anything, and this dot head, as in this dot head dot next, head as in this dot next, which in the sense we now we have one more thing we need to, if this dot head is equal to null, what we have to do, we have to say that, hey, the linked list is empty. What should I do with it? What should I do with it? Right? So we can say, yeah, just return null. That's what we wanted. Okay. Or and also we have one more case here. If the next node is null, yeah, no, I think let's check if it's working or not. So insertion, deletion at start, right? Let's copy this thing. And the insert at index, and let's see. So here, let's remove this. So 23, 3, 2. So the 23 need to go. Yes, this is working properly. Okay, so let's check the base condition is working or not. I mean, the error condition. Yeah, that's also perfectly working. And this one too, just to make sure that everything is working. Okay, so this is working properly. Now let's move on. So if you want to explain me what happened, pretty simple, right? You can literally do this. So what happened is, so insertion or deletion at the first node, what is happening is we have the next node as a next. We have the next referring to the next node, right? So we will set the head it to the next node, which means this portion will be in this next node, and then next linked list, which is basically listing all the things. Got it? Okay, cool. Now let's move on to the next deletion at the end, which kind of pop, where we have an array pop method. So if there is no node, this dot head is equal to null. Oh, we can do like this too. So which means if the head is null, it will work. So we'll return null. Else, what we want. Now we want to iterate till end. All right, till end. Yeah. So let current assign this dot head. We will keep a reference of this head to iterate the best practice. I hope it's the best practice. Yeah. And we will iterate till current dot next is equal to null, or current dot next is equal to null. So yeah, wait, let me think. There will be a problem. Current dot next. What if the next node is not there? Yeah, let's see. Current assign current dot next. Yeah, basically it will iterate till the previous node of the end, and we will set current dot next assign what current dot next assign null, or yeah, we can set it as null. So let me check if it's working or not, and I will explain you. So here we want to delete the two value, right? Okay, oh, cool, working properly, no problem. Let's see if it's working. Yeah, cool. And we are checking. Yeah, here is the error. So the error says that this dot next is not available. It is null. So basically what we have is a single node here. Yeah, this node. So we don't have next dot. We we literally don't have the next, and we are trying to access next dot next. So it will not work. So what we want is if current dot next, if current dot next and current dot next. Yeah. So delete at the end and current dot next. Okay. So yeah, this is one more the problem where the linked list contains one node. What we have to do? We have to set it as null, right? So head next is not there. If it's not there, what we want is dot head as a null. That's it. Cool, right? I think you got it right. Yeah, let's see it's working or not. Oh, we have to return it. Otherwise, oops. Okay, cool. Okay, so it's working properly. So what happened here is we tried to access or we tried to delete a node of its n, which where the linked list contains only one node. So if it contains one node, we will do this. I mean, we will set head as null. Uh, yeah, that's pretty much. And let current is equal to this node head. We will iterate till the end, which means before the end. I mean the node before the end. So for example, let's see. Let me clear this for you. Okay. What? Okay. So here what it happens is it will work. It will check while current dot next not next exists. So this is the current value. Next dot next exists. Yes, it's exists. So it will go. It will set current as in current dot next, which means this now. Now it will check if current dot next exists. Yes, current dot next is exists, yeah. And the second condition will be false, right? If current dot next, which is already existing, and the next it is not existing, it is null. So this the loop will not work. And what will we do? The current dot next is we iterated till current dot next, which means till 3. And the last node is second the value node with half no 2 value as 2. Okay, whatever. So we will set as null. See, so if I do this, yes, what happened? We'll set current dot next as null. Got it? I think you got it, right? I mean, this is one of the best explanation that I ever could give you. And delete at a position. Okay, let's do this. So in order to delete something in a position, uh, yeah, let's do this. Delete at index, or at, yeah, at index. Delete index, yeah, the name index, and the index will be here, and we'll set this. So okay, if there is nothing, you have to, yeah, you have to say that it's the hey, the given index is invalid. Give me the proper index, right? So more than that, let's do the main logic, and after that, let's resolve the error conditions. So let current assign this dot head. Okay, cool. Now what we are going to do is we have to iterate till the position, so or till the index. So we will set a variable as position, and what we can do is set as 1, and we have to, as we did before, we have to iterate till the position or it insert at index, right? So here what we had have done, iterate till that position. So we will iterate till that position. So let's see, while current dot next should need to be accessed and position not equal to, or we can give a break condition inside that loop. It's totally up to you. You can do whatever you want, right? So like nobody is going to stop you. So it's all about you, what you think. Yeah, I mean, that's something like. So here what we have to do is we will iterate till the node, till the index. So before that, what we need is we need to delete before the node before that. So oh yeah, I got it. So here we can set that index -1, or what we can set. Yeah, let's see. Yeah, I first let's implement this, and I will explain what is the problem is. Current dot next, current assign current dot next, and it will iterate. And here current dot next dot next. Yeah. Now let's see. Insert at insert index, delete at index. Yeah, the naming conventions are not really good, but you have to properly follow it. So I need to delete the second index. So if I said second, let's see what happened. Yes, there is an error which says that current. Oh, yeah, there is no current dot next. So this is a problem that I have never faced. So let's see how to resolve this. So current assign current dot next, which in the sense which don't. Let's see if it's this is working or not. Yeah, cool. So we have deleted the second node, which means this need to be 0, right? And yeah, now if I set 1, the other problems are there. So I think you got it. What's the problem is? Yeah, we are missing something. Can you spot that? I mean, no, there is no time to spot that. We didn't incremented the position. That is one of the problem of here. And let's see. Okay, so here 1 in the sense 0, 1, 3. Oh, this is working unexpectedly. So let's give why did I give here 1? Let's give 1, which means 1 removed. Yeah, perfect. And if I give 1 in the sense, we will giving this as this, and if I give 2, yeah, the 2 is also gone. Wait, let me check. I have, let's give it 3. Okay, 1 2 3. Okay, let's clear this time. Now if I give this dot this, and if if I give the position to 2, yeah, 1, 2, this must should be deleted, right? So what we can do is set it as 2 or decrement the index. It's totally up to you. I think there is other better solutions for this. So now, for now, what is coming into my mind, or what comes out of my mind, is decrement it. That's all we needed, right? So here, if you go to, yeah, it will return 2. And if current is equal to null, so we have to return, oh god, return null. Yeah. So I think if I give 1, it will decrement into 0. And yeah, why it's not returning? Oh, seems like we have a problem here. Let's see what delete at index we will have. Let's debug. Let's remove this, none of it. So what conventionally happening is we are going here and setting position as 1, and we are setting iterating till the position, which in the sense, and if there is no null, if there is no next. Okay, so here the problem is that we don't have next. So if we don't have next dot next, what we want, I mean the next dot next will be null, right? Then why it's not working? So I think, yeah, let me debug some more times and I will get back to you. If I debug from here, it will take a long time. So yeah. Okay, nothing is here in my mind. Let's first of all, let's clear all the edge cases, so that will be better. So if index is less than 1, and also if the head is null, you have to return null, right? If, oh sorry, less than 1, you have to return, uh, wait, or we have to return null, return, return, or if this dot next does not exist, if it's not exist, that we will return also null. Okay, cool, not a problem. Now then if we run this, okay, so let's examine the problem. What is the problem? Okay, now we are starting it from 1, right, in the first index, right? So here what we have, what if the index is 1? That is an edge case, like we are giving it next and if the index is 1, so we have to do that, we have to cover that thing too. Index is equal to 1. It's cool, I mean it's pretty simple. This dot head, assign this dot head dot next, yeah, I have to return that. Cool. Now if the index is 2, works totally fine, and here we need to decrement the index or set it as 0. So what we need to do is, let's decrement this. Now let's see what, here we are trying to delete the first node, right? Okay. Okay, cool, not a problem. Now let's see if it's deleting the second node. Okay, it's working. And next, Let's see if it's working. Okay, cool. So here what's the problem was, while initially what we have given is index as 1. So here index, if we didn't resolve the problem of, or the edge case of our index comes of first. So yeah, that was the problem. So it will not came to here and it will have the error of next dot next is not exist. Yeah, that's true. Next dot next is not exist. Even though it's null, we cannot access that null property. Okay, I think you got an idea, right? Let me format it. I don't know what's the formatting code, but yeah, that's cool. So here I think I have explained, and if you want to look it, you can pause it and try to iterate through it, and you will get an idea. Okay, so we have done that thing too. Where is that X? Yes. So we have successfully completed the deletion operation. Okay, so yeah. Now let's see traversals such as search and display. Yeah, it will be very simple. Let's hope it will be simple. Okay, let's remove this. Okay, let's close this, close this, close this, and close this. It will take a moment. Okay, so we have closed all the things. Now we want to display. So in display, what we can do? See, in most of the cases, what I have seen is creating a new variable and uh, or creating a new array and push the values into it. So yeah, let's do the same thing. Let current assign this dot head. Let uh, values or what values, let's say values assign this dot head. I mean, sorry, this is an array. God, how can I follow? I mean, how can I think like that? Okay, now we have to iterate while if there is no node, right? Okay, so while current dot next, we don't have current dot next, or why current is not existing. What we can do? Okay, let's go through it. Current first value dot push current dot value. Okay, and let's trade it current dot next. Okay, cool. So it will work at the end if this is null. Yeah, if it's this null, it won't work. So what I have concerned was, if the next thing is null, it will push null into it. So let's see if it's that thing is really working or not. Values. Yeah, not a problem. So let's call this console, no, ll dot display. Cool. Okay, so yeah, fine, cool, no problem. So now what? Let's make it this more. What is that? Let's join this. So join with something. So this is the traditional displaying what we used to see. So wait, let me quickly remove this thing so you can see that. So here the first node is the first node is this and the value is this, and it is referring to the next node, and yeah, like that. It is working like that. Okay, looks great, right? Yeah. Now what we have to do is search. Now search. Let's see. Now here, let's close this. Search. Search as in value need to be a value. If there is any value, we need to return as true. I mean, if there is any value like that in the linked list, we need to return true. That's all we wanted. Pretty simple, right? You can do it your own. Start head and while else we can return false. Okay. So let's search a value inside a console log. It's taking too time. Let's see. True. If it's not there or not. What is true? Where is my true? Where is my true? Search value is there. Oh, oh, sorry. Oops. I have forgot something. I have never iterated it. So in order to like in for loop we have I plus plus which will refer to the next value. Here we are going to next. So we need to go to the next side, right? So current assign current dot next. So that must work. Yeah, true. Now let's see if there is if we give an invalid thing. False. That's cool. So yeah, that's all about the travel cells. And if you want, you can try it everything yourself. And also, I will provide the GitHub link of this. So if you want to refer this, you can refer. You can go ahead and give a like for it, like that. And also, in this case, there is something in linked list. In simply linked list, we have this dot tail, which basically give a reference to the last value, last node, right? So I believe that it is not a problem. So let's do like this. No need of extra memory space, right? We can figure it out. Like even though I'm lazy, okay. So traversals. We have done traversals and search, such as search. Good. Now the most important part of this video, advanced topic, reverse detect cycle. Sorting, sort linked list. Okay, cool. Merge to list. uh, Merge to list, which is pretty simple. Okay. Remove duplicates. Okay, cool. So let's reverse the linked list first. Reverse. So for that we need a method reverse, and we need what we need. So here, this is one of the most complicated operation when it comes to linked list. So here what we can do. So in order to make you what is really happening here is first of all let me go through what we are going to do so you will get a better idea about how it works. So here let's assume that this is a linked list. What is this? Both are same, right? Let's remove this. Okay. Let's assume that yeah, this is a linked list, right? So this here what we need is the next need to be in the this need to be reversed. Okay. Okay, reversed. How can I do that? So in order to reverse, what we can do, we can give this to the next of 2 and give this to the next of 3. Okay. I got it. You don't understand this. So what we are going to do is give this node as the next of second node. Okay, cool. And give the second node and next node. I mean, second node and first node as the next node of third node, which is basically a kind of reversal. I mean, it is a reversal. So yeah, let's do that. I will. If you don't get it, don't worry. I will explain at the end. So yeah, let's keep let null. So basically, in here the problem is if we are making changes, right? So we need to get the reference of the next values. I mean, if we change the starting node, so here if we change the starting node of next, which contains all the next values, this will be gone. So this is not what we wanted. This not should be a happen. I mean, this not we wanted. So first let's give as this dot head, which will keep a track to the next node, next node, next node, right? So it will, in every iteration it will like what save the next node for the next operation, like that. And let what current assign this dot head. So in current we are going to basically make changes, and then we need previous. Okay, cool. Now in order to change it, we need to iterate it, right? So sorry for that. So here what we can give is if next exists, need to the loop needs to continue running, right? Okay, cool. Now uh, here we need the reference of the next node. Okay, so in next what we are going to do is next dot next, or we can say current dot next. No matters. Yeah, next dot next is cool. And I mean next dot next contains the head, and we will keep. I mean we will store this value for the next operations. And here what we are going to do is initially the first node next need to be null, which means this is the first node that is going to be in last. So what the last node's reference is null, right? So in order to make this null, the initial condition or the current node dot next, which means first node's next, is equal to previous, which contains previous. Okay, cool. I think you have understand this. And in previous we will set that current. Okay, so we will set this current into previous. We will set the initially we will set this current dot next is equal to null, which means this all things will go, I mean will be null. So that's why we are storing here in the next, or in the next for the next iteration. Okay, cool. And in the next and in previous we will store this node with null. Basically here will be null, which means we only have one. Okay, cool, not a problem. And in current what we are going to do is next. So here we will set next, so it will iterate. So what if I say this is all about reversal, and also we have to set this dot head as in previous. So this is all about reversal. I mean, let me check if it's working or not, and I will explain to you. So yeah, display it and ll dot reverse and ll dot display. L stands for linked list. Stands for linked list, right? Clear. Okay, cool. Okay, okay, it's working properly. So here, what's happening is we are we're assigning three variables at next, current, and previous. So next will keep the next value. So what here is happening is next will show this much values, and initially we will take this one and we will set this one's node to previous, which means initially it will be null. So this is the node that we wanted in the last position. So this dot null, this dot next need to be null, right? So that's why we need that. Okay. Now in the second case, here previous, and we will current dot next, which means we will set current to this value, this much value as next. So here, here what we are going to do is second node dot next assign what we are going to do 1, which means second dot current means second node, right? So current dot next assign next means instead of this we are going to set this node. That's what's happening here. And in the last iteration we will have, we will take this much thing and set it over here. Okay. Okay, so that's all about the working, and if you don't understand this, please rewatch or try try implementing yourself, and take a pen and paper, go through the iteration. Then I swear that it won't understand in the initial phase or in the beginning and the first iteration. You have to go through it. Then only you will understand. Okay, cool. So yeah, so here we have gone through the reversal. Now detecting cycle. So in linked list, a cyclic linked list is called where it is an endless loop. Let's say we can say it will at some point it will refers to the head node. So this it will be something like this. Uh, one, so two, three, then one. So this is an endless loop. So how can we detect this as a loop? I mean, this is basically this goes on. So this is basically called circular linked list. So how can we detect this? Detect cyclic queue. So yeah, is cyclic. So in order to check that, with the help of two pointers, I mean pointer technique, or we can set 2 pointers. One let slow, and I mean I think you are already familiar with these things, right? Like this, I'll explain it. Let first say this dot head dot next cool next. Okay. Okay. Now what we want is while fast and fast dot next existing. If fast and fast is existing, it will iterate. So slow sane. I'll explain at it at the end, so you will get an idea. And then fast as in fast dot next, and if in anywhere. So here what is happening here is, let's take an example of it. So in circular it is an endless loop, right? So let's think about it as a what we can as a stairs. So here we have a stairs which is in an endless loop. So initially, let's say initially it's a loop of five steps. So in we want to cover 5 steps, right? So what does the slow pointer and the fast pointer will do is, slow will try 1 step and the fast will go 2 steps. So the next step will be the flow first or the fast, like it will go more than what slow is going. So for example, if slow dot next, the fast will go to next. For example, let's assume that this. is the stairs. This is an unless loop. Okay. So here slow will be here and fast will be here, right? In the next iteration, so slow will come to here and fast will go two step forward here. In the next iteration, it will go to here and it will go to let's say this is right. So it will go to the here. Basically, circular in the sense it will go to one. Let's see one more time. Let's see. So this is an it's like a loop, right? The this dot next will be referring to the first node, right? Okay. So this will be slow and slow dot next is the fast pointer in initially and slow dot next it will be here and slow dot next will be here and here slow dot next will be here, slow dot next will be here slow dot next will be here, here slow dot next will be here and like fast dot next and here like in this portion if someone walks one step and the fast pointer will walk two step ahead. So in some case slow fast dot next checks will reach here where the slow is reached. I mean it will reach or it will reach the point where it will started or the slow is it's like a uh, what we can say a crocodile's race where we can say that the one guy is completely completed the loop and then it is also starting. I mean you got the point, right? Yeah, so that's basically it. It's and there will be a point where slow and fast will reach at the same point and we will get to know that it is cycle. So so fast, slow is equal to fast, return true. Yes, this is a cycle. Else, which means return false. False. Okay, cool. Now let's see it's working. If this working or not, I need to console it. So dot log ll dot is cyclic. Okay, false because this is not cyclic, right? So yeah, in order to make a thing cyclic, it is very simple. Just give the reference of tail dot next to head. So it will be refers to head and it will work like an endless loop. So yeah, that's pretty much it about the cycle detection. And in sort list. So in order to sort a linked list, we can use what we can follow the bubble sorting. Okay, so let's sort a linked list. So here we have two methods. Most of we can try the merge sort or anything. So for this we are going to sort a linked list using bubble sort. So okay, so we'll set current as in and we need to iterate it while current and current not next next. Oh, okay, this need to happen in a do while loop. Okay, do while. So we need some conditions in order to work this. So while let's give what is the base condition where it needs to be work. If it's something inside this is swapped, I need to rerun this loop, right? Yeah, you will understand after is swapped. Swapped, I think. Yeah. So this initially swapped will be what swap will be false. Okay, and inside this loop we will iterate it, and we will let okay, okay, got it, my bad. So inside this we will set this as head. Okay, cool. Now we will iterate it. So in bubble sort we need to iterate for from beginning till it ends, right? So it will start, if it's sorted it will start from the beginning and it will check and will check like that, right? It kind of goes in a bubble manner, it will pop up like that, right? So let's do this same here. So here inside loop, and we can check if current dot next dot value value is greater than current dot value. If it's greater than, what we can do, we need to swap the not the nodes, we need to swap the elements. So if it's a number we can swap it, right? So let temp assign current dot next dot value and current dot current dot value assign temp. Sorry. So here we, okay, cool, cool. No, no. Next dot value assign, what we are going to do. We will assign this into current dot value. Okay, cool. Now in current dot value assign temp, and here we will set that is swapped true. Yes. So else, yeah, even though if it's not work, yeah, we need to iterate this thing, right? Next, cool. So let me check if it's working or not, and I will explain on the way ahead. Like while coding, explaining will take a big amount of time. So let's see. Let's do this. Okay, I think everything is fine here. Oh, we need a false condition, right? Else, what we are going to do? So here, yeah, no need of this. Let's check. So here, let's give 112. Yeah, undefined. Cool. Not a problem because we are logging it and we are reversing it. Okay. So here, yeah, it's working properly. Okay, I will explain this. So this is sorted in an ascending manner. Yeah, that's what we wanted, right? So here, in order to sort, in order to sort a linked list, we have initially set a value or is swapped as false. As nothing. And what does do while loop do? It will initially it will run once, and then check if the condition is satisfied. Then only the do while loop will work again, right? So that's what happens here. So then we will set as false initially, and current dot next is next. So every time it will restart, every time this work it will check uh, if it's check it is sorted or not. and if we will check the value, we'll iterate it, and if it's less than, cool, no problem. If it's greater than, it will swap it, and we will set swap as true. After this, we will check we need to work again. So if we swapped anything at the end, I mean while going, it will work again. And it will check. It will work until the is swapped is false. So yeah, this is pretty confusing, but after some times you will get to know this is pretty simple. I mean, this is the basic concepts of like that. I mean, this is the basic concepts of sorting. You just need to understand the how iteration in linked list works. Singly linked list. I forgot to mention that singly linked list. Singly linked list. Okay, cool. So now what we can do? Yeah, let's see. So here I have done the sorted English. Now in order to merge, it is very simple. I think you can take it as a task. Do it yourself. I mean, it's pretty simple. If you want, you can comment it. I will make a separate video on it. But this is pretty simple. I mean, just give the second list's head to the last node of the first node. So yeah, that's is basically it. No need to worry about this. So let's remove this thing. Oh, let's keep that in. And now the last method is remove duplicates. So in remove duplicates, there are some ways. So here we are going to follow the set method. With the help of set, we are going to remove the duplicate. So yeah, let's see. Dupes, dupes. Yeah, that's that's seems good. And let current assign uh, this dot head. Let set assign new set. Yes. Okay. Now what we have to do is we need to check if anything. First we need to iterate it. Then we need to check if the value is existing or not. So we are removing the duplicate node which have the value. Okay. So while current exists, current dot next exists, will go to the, and if current dot next if current dot next and if current dot next dot value is equal to, I mean, if current dot next dot value is in the set, if it's in the set, we can, let's check first. Set set dot hash. So if it's false, I mean, let's say if it's true. So basically we are iterating it, and if there is, we will iterate or we will insert the values while going, and if there is something exists inside the set, we will move the node to next dot next. So yeah, that's will be the case. Okay. If it already exists, we can say that current assign current dot next. So else, in the else case, current assign current dot next, that works properly. And here the problem is we are not setting the initial current node's value. So set dot add current dot value. Okay, now it must work properly. I think so. Current dot next. Oh, we are overriding it. That is not the proper way. Okay, here if we override this will be a kind of iteration, but we are setting into the next node. Okay, cool. Okay, now let's see if it's working or not. Let's give some duplicates. Yes, that is working properly. Uh, if I give some other duplicates, what we can say that mm, any other one one what happened 1 1. So this is a problem, right? So at the end it is pushing and then it is not working. So here what we can do is let me debug it very quickly. Okay. Okay, cool. So I got the problem is we are not setting we are not adding the value actually. We are just iterating it, not adding the value into set. So current dot value, we'll set that. Current dot next value, all right? Current dot next value, which means we are going through the next values. Okay, cool. So it's working. So this is the original linked list. This is the remove duplicate remove linked list. So what was the problem was I haven't added the value into set. So it will check if the value is there and it only works. But here for the first iteration it works because we are already added into it. So that's why it's working. Now it is working properly. You can see that. Yeah. So I know this is the advanced topic is pretty confusing. I mean, more confusing. I also felt like that while explaining, but it will everything will make sense eventually. So if you don't understand this, just take a pen and paper, try to write it down, and you will eventually understand what is happening here. Try to traverse through each node what happening is, each line what is happening, like that. Then you can be a master in linked list, singly linked list. I mean, you can be a master in anything if you have the mindset to iterate through lines. I mean, what happens to debug? Like you have to build up that debugging mind. So we have covered the duplicates removal. So basically, we have covered all the operations such as advanced and the normal operations. So these are the operations that basically comes in uh, linked list. So yeah, so this is a task for you. You can do this. Come, if you can do this much, you can literally do this. Just think what we have to do in order to merge two linked lists. Okay, so here we have a linked list of L1. Let's say L1 and L2. Okay. Now if we set the L1 dot ends at the end of this what we can say at the end of this linked list we can L1 dot next as in L2 dot head, like L2 dot head, right? So this is the kind of merging, and if you want you can sort it and everything like that. So basically that's for this video, and it's almost it's totally half an hour, almost 1.5 hours. Oh god, yeah. So that's all about this video, and if you liked it, if you understood it, and if you feel like you need to improve in certain thing in explanation, Please comment it out. I will definitely try to improve it. And yeah, I know this is very hard, to say something while looking in the code. So I will definitely try for the upcoming videos. I will try to add some graph representation or something like that in order to understand very well. And yeah, I think that's all about this video, and I would like to conclude. So thank you for listening this far, and thank you for your support. So that's all about this video. See you in the next video. That's all. Thank you.